Alright, so I think this is recording, or at least I sure hope it is. Okay, I have a rational function. Now, even though this numerator is a constant, we, we, um, we do consider constants a monomial, a polynomial, a constant of just one. In the denominator here, we have a polynomial of degree 2 with a leading coefficient of 2. We want to factor the numerator and denominator. Well, the numerator is just 1, so we don't do anything with it. In the denominator, all of these terms are even numbers, so I can factor out a common 2. I'd be left with x squared minus x minus 2. Alright, so can we factor this guy? Well, we hope we can. If we can't, we can use the quadratic formula. That looks like it does factor. We've got x minus 2 times x plus 1. Because we needed two numbers when multiplied together give me negative 2, but when added give me a negative 1. Alright, we found them. Now, it wants us to identify the domain, and we always do that before we try to reduce the function. So the domain of this function f in set builder notation is the set x such that x is an element of the set of real numbers, and the x we exclude the number positive 2, it causes division by 0, and we exclude the number negative 1, it causes division by 0. You could choose to write this domain in interval notation from negative infinity to negative 1 because negative 1 is smaller than positive 2. So it's to the left of positive 2, and you throw out 2. So either one of these is acceptable for the domain. I'm going to erase this one and just write below this x equals 2 and x equals negative 1. When you exclude things from the domain of a rational function, it will appear in the graph. You'll either be able to identify a hole in the graph or what they call a vertical asymptote. So holes in the graph are created when common factors cancel. We had nothing that canceled here, so we have no holes in this graph. We do have variables in the denominator, and they are going to appear in the graph as what they call vertical asymptotes. Vertical asymptotes are lines, vertical lines. It's the line x equals here, in this case 2, and this vertical asymptote, because there's two of them, is the line x equals negative 1. And we're done. It wanted us to identify the domain, and we did that. It wanted us to tell the location of any holes where there were not any holes, and to identify vertical asymptotes, and there were two vertical asymptotes, the lines x equals 2 and the line x equals negative 1. Let's do another one on this video. Let's look at this next one. Again, the numerator and denominator are polynomials, so I know this function is referred to as a rational function. They want us to determine the domain and see if there are any holes or any vertical asymptotes in the graph. First thing we want to do is factor both the numerator and denominator. So if I factor x squared minus 9, that factors to x plus 3 times x minus 3. And I'm afraid of sign errors, and it's awkward for me to factor when I have a leading coefficient of negative 1, so I prefer to factor out a negative 1, which is going to change the sign of every term to where now I have a positive leading coefficient, but then this will be minus 2x and minus 3. Because if I distribute that negative back through there, this is what I get the original. So I can still factor this denominator. I've got the numerator x plus 3 and x minus 3. And the denominator, I have this factor of negative 1. But I need two numbers when multiplied together give me negative 3, but when added give me a negative 2. So I believe that's going to be x plus 1 and x minus 3. Because a positive 1 times the negative 3 is negative 3. And when you add positive 1 plus a negative 3, you get negative 2. So I'm ready for my domain. I want to always do my domain before I cancel any common factors. The domain is the set of all x where x is a real number. And we're going to throw out negative 1 from the domain because it's going to cause division by 0 if we input negative 1 into this function. We're going to exclude positive 3 for the same reason, that if you evaluate this function at positive 3, you'll get a 0 in the denominator, so you don't have a corresponding y value. Now, let's look and see, does this, and we could express this in interval notation if we wanted to. All right, let's look here and see, does anything cancel? I have an x minus 3 in the denominator and an x minus 3 in the numerator, so those cancel. When we exclude things from the domain, it's either going to appear in the graph as a whole or what they call a vertical asymptote. If you have factors that cancel, it creates a hole. And since x minus 3 equals 0 has a solution of x equals 3, it's this x equals 3 that's a hole in the graph. So a hole has an x coordinate and a y coordinate, and we just found that the x coordinate is 3, and we'll have to come back in a second and figure out what the location, what the y coordinate is. What did not cancel, what still remains in the denominator, is this x plus 1. This x plus 1, we want to prevent it from being 0, so we wanted to prevent it from being negative 1. Alright, so here it's going out, but in the graph it appears as a vertical asymptote, which will have the line x equals negative 1. Alright, so let's come in and figure out this y coordinate of this hole. Well, we returned to the function in factored form, and we had canceled it, but we didn't really write out what the resulting function was after we've canceled this out. Our numerator is x plus 3, and our denominator is negative 1 times x plus 1. So to figure out what this y value is, if I plug 3 up into the original function, it's going to be undefined. It was thrown out of the domain because it caused division by 0. But this new function has been reduced where it doesn't have x minus 3 in the denominator. So if we plug in, if we let x equal 3 into this reduced function, in the numerator we'll have 3 plus 3, and in the denominator we'll have negative 1, and then we'll have 3 plus 1. Alright, so 3 plus 3 is 6, and 3 plus 1 is 4, and that's a negative number. Those are both even numbers, so they would expect me to reduce this to negative 3 halves. So this hole in the graph has coordinates 3 comma negative 3 halves. We found what they wanted. They wanted the domain. They wanted to know from that domain, if you exclude anything from this domain, how does it appear in the graph? We found a vertical asymptote of the line x equals negative 1, and from excluding this 3 from the domain, there's a hole in the graph, and the location of that hole is 3 comma negative 3 halves. Hey, I hope that helps, and I'll talk to you later.